Welcome. In this particular talk we're going to have a look at the role of graphics within 2D games. It will be a short, hopefully sweet talk because we just want to cover some of the basic characteristics and uses of 2D graphics. So we'll start off first of all by having a look at some of the things that we will use graphics for within our games, and in terms of what's being displayed, it's going to be basically everything. So some of the roles, they include obviously the game objects that we have within the game. So we will, depending on the game, you'll have a number of key entities or key objects. You'll want to render those probably using some form of bitmap graphic. The decorative aspects or any of the background components, again, those two are likely to be images that sort of help convey whatever scene it is you are trying to create. For things like animations, depending upon the type of animation that you're doing as opposed to sort of a moving object, if you are looking at an animation that you play back, this is simply a sequence of images where each image happens to correspond to a different frame in the animation. And one of the later lectures we'll have a look at how we can write a little piece of code that will go through and to pick the appropriate frame and to play it back at a meaningful speed. It also applies to character sheets. So if you want to display fancy text or numbers on your game, quite often you actually download a sprite sheet that contains the characters, the glyphs that you want to use, and you are then mapping a particular character onto a rectangular region within your sprite sheet, part of the image, and you're drawing that out by way of drawing whatever character you want to draw. Special effects as well. So we'll look at things like particle effects. They're nice and they're fancy, but in essence they're just simply 2D objects or 2D graphics that are drawing multiple times with different fades or different sizes. And finally we have our HUD elements, so anything you want to display to the user on top of the game, quite often we'll have some graphical embellishment to those as well. Just a very quick aside, we are talking about 2D games here. Also for 3D games, 2D graphics actually play a key role or key component in terms of how a actual surface gets to be rendered, to be displayed. This comes into sort of the material notionally that a surface is rendered with. So there's lots of different types. One example here is of a diffuse texture. So diffuse is just the normal in sort of looking at it down under basic lighting, how does the thing look like? So this actually is sort of a pebbly surface. But alongside that you can have other images that describe some of the characteristics of that surface or that material. One's a specular map, so this would be stored as an image, but we're not storing color values here, we're storing numbers within it that tell us how shiny or how reflective the surface is. You also can have normal maps, where again it's a 2D image, but the X, the Y, and the Z values within this hold the normal to the surface. In other words, if you were to sort of zoom down into it, what way does the surface point at a particular point? Now, some bits of the rocks will be pointing straight up, other bits are going to be on the side, they'll be pointing out, and the normal map sort of captures the curvature of that surface. You can also have things like height maps or depth maps, and they notionally record relative to other points within the material how high or how low something is. And taking the normal diffuse, how it looks, combined with these other informational maps, you can actually do lots of fancy 3D rendering things with it, including things like parallax offset mapping, or parallax occlusion mapping, where you can take and get renders like you see over on the right hand side, where something that looks three-dimensional, as you move the camera around, the textures and the shapes would change, and it would do a remarkably good job of conveying that this looks like a 3D object, even though it's simply built up of a number of 2D images. So a little bit here about image characteristics. This will all be reasonably familiar stuff to you. When we think about an image, we can define it in terms of its type. So we'll mostly be using bitmap images. We also have vector images as well, which would describe it in terms of lines or rects or fills or whatever. Dimensions, which is the size of the image. In terms of bitmaps, it'll be the number of pixels and the width and the height. Channels. So for each pixel that we have on it, or texel in terms of a texture element, what values describe that particular element of it? What channels are there? For the stuff that we are using, we'll assume we have a red, a green and a blue, the 3 primary color channels, and a 4th one for our alpha value, which tells us how opaque or how transparent that particular element is within it. We also got a color depth, so this is for each of the channels. How many bits do we need to store for that channel? Most of the things that we'll assume a 32-bit sort of RGBA, red, green, blue, alpha. So for each of the channels holds 8 bits. In other words, there's 256 possible shades of red, shades of green, shades of blue, and all the combinations thereof, which is ample for any of our games. We also can have a compression type as well. Images are fairly memory intensive. So how they are stored, this can be on disks. There's also some hardware compression by way of storing it in video memory too. But how it is stored will be an important component about the amount of space, particularly that we'll need to set aside for packaging up or throwing our app around. So let's look at some of these. We'll have a look at the alpha channel. This will be quite important within the game because we'll want to layer our graphics and we want to expose some things that are visible behind other types of graphics. So 3 different types. If we have an image that doesn't have an alpha channel, or if we have a channel that is fully opaque, then it means that whenever we display it, it will cover whatever is behind it, fully behind it. And generally we don't want to do that other than our background, where we want to have one main background covering the whole screen. If we have an alpha channel and it has a sort of a non-full value within it, then this enables us to transition the full spectrum between transparent and translucency. So a transparent image is one where each of the texels within it, the pixels, they're either visible or not visible. Either you see it fully or you don't see it. And notionally here for this image, the red line that we have going across, either we draw something on top of it or we don't and it's visible. And transparent images we'll use quite a lot. That's probably the most common one you will use. You can also have translucent, and if you look here, for example, at the center of the red die, you see that you can see the checkered pattern in behind. And for translucency, you can control how much of the background you want to have seep through and how much you want to have replaced with the image that you're drawing on top. So for things like clouds or some special effects, you'll want them to be drawn with a degree of translucency. How these images get to be combined, so how I can take a source image and draw it on top of a destination image, is a process known as compositing. And we'll look at compositing in a later talk. There's lots of different ways you can do this and different effects you can sort of tease out by way of how they are combined. Some of the common image types you can see here for bitmap, for JPEG, for GIF or GIF, I think they believe it pronounced, or for PNG. In terms of the type of compression they have, the color depths they support, transparency and translucency. I would suggest for this particular module, simply use PNG formatted graphics. They would be perfectly good, perfectly suitable to use. We also have an image repository available as part of the module. This is one that students in previous years have put together by way of the images they have collected, and is going to be available for you to access and to use to help you develop your own game. In terms of the repository itself, it has a number of different aspects. You have some HUD elements, there's some sprite sheets, tile sheets, some animated files. have an explore of it and try to find something that sort of fits in with the game that you're looking at. You can also, Google Images is particularly good if you're searching for the right term. You can find a lot of good quality graphics out there that you may want to use within your game. If you have some artistic ability yourself, you may want to sort of roll your own graphics. But again, stress and be mindful here that you're being assessed on the quality of your programming, not your quality to create nice graphics. So the emphasis is very much on the programming side within this particular module. Bit of the button's important, that about copyright infringement is wrong. So a lot of things we can use for academic purposes, but be very mindful. You need to ask permission. Make sure you do have the right permissions for the images that you're using. If you're going to push up anything onto the App Store, you need to be watertight in this. You need to be extremely careful about what you put up, the graphics and the sounds, or to make sure that you've sort of created it yourself or got appropriate permissions for that. A little bit of an aside here, you can read this yourself. It's if you are downloading things and you maybe want to cut away the background to make a transparent or translucent image, a lot of your image editing software, so things like GIMP is a free one, or Photoshop, which a lot of students seem somehow magically to afford, you can use those by way of helping you to extract foreground from background. Key takeaways in this, I only have 2 of them. Almost certainly you'll be using lots and lots of different types of images within your game to do lots and lots of nice, interesting things. And do have a look at the image repository about trying to find graphics that are acceptable within your game. You could spend an awful lot of time looking for graphics that are perfect. I would suggest, from our point of view, getting something that's good enough is indeed good enough. Particularly that because we will be looking at the coded implementation, not necessarily the quality of the actual visual quality of the graphics themselves.